Just when you thought AI couldn't get any better, NVIDIA drops NVLM 1.0, and it's turning the industry on its head. Known for being the frontrunner of AI innovation, NVIDIA has consistently pushed boundaries, and NVLM 1.0 is no exception. This new model has quickly captured attention for its groundbreaking capabilities, making waves in both vision language and text-only tasks. But what makes it so revolutionary? It's not just another AI model. It's a game changer that rivals even giants like GPT-4 and Llama 3V. By seamlessly integrating vision and language tasks, NVLM 1.0 redefines what we thought was possible. Imagine an AI that can not only analyze images, but also solve complex math problems and improve coding performance, all while outperforming its competitors. The industry hasn't seen anything quite like it, and it's sparking conversations about the future of AI. So, what exactly is NVLM 1.0? In simple terms, it's a frontier-class multimodal large language model. But what does that mean? Multimodal models are designed to handle both text and visual inputs, allowing them to excel at tasks that require an understanding of both formats. While similar models exist, NVLM 1.0 stands out by not just competing with, but often outperforming the biggest names in AI, such as GPT-4 and Intern VL2. One of the most exciting aspects of NVLM 1.0 is its dual strength. It doesn't just handle multimodal tasks, it also improves its performance on text-only benchmarks. For example, while many multimodal models experience a drop in text-based performance after training, NVLM 1.0 defies expectations by boosting accuracy on math and coding benchmarks by an impressive 4.3 points. This is a game changer for researchers and industries that rely heavily on text-based tasks. And here's the best part, NVIDIA has made NVLM 1.0 open source. Its model weights and training code are freely available through Megatron Core, NVIDIA's cutting-edge AI platform. This move democratizes access to state-of-the-art AI technology, empowering researchers, developers, and organizations to innovate without barriers. When it comes to performance, NVLM 1.0 seems to dominate. Let's talk benchmarks. On OCR Bench, which tests optical character recognition capabilities, and VQAV2, a benchmark for visual question answering, NVLM 1.0 achieved state-of-the-art results. But it doesn't stop there. It also excelled in MathVista, ChartQA, and DocVQA, proving its prowess in reasoning and multimodal tasks. What makes this even more impressive is how NVLM 1.0 stacks up against its competitors. Take GPT-4o, for instance. Widely considered a leader in AI, GPT-4o now has serious competition, as NVLM matches or even surpasses its performance on most key benchmarks. Another rival, Intern VL2, shows significant degradation in text-only tasks like MMLU and Human Eval, making NVLM's consistent excellence across both modalities even more remarkable. And then there's Llama 3V, a highly anticipated model whose weights have yet to be released. While Llama 3V avoids degradation in text-only tasks by freezing its backbone during multimodal training, it doesn't achieve the same growth seen in MVLM. NVIDIA's model manages to enhance both its multimodal and text-only capabilities, a rare and valuable trait in the AI landscape. This dual strength is what sets NVLM 1.0 apart. It isn't just excelling in specific areas, it's excelling everywhere. That kind of versatility is a huge leap forward and positions NVLM as a leader in the rapidly evolving AI space. So, what's the secret behind NVLM 1.0's success? It all starts with its architecture. NVIDIA has combined the best elements of two popular design approaches: decoder-only models like LLAVA and cross-attention-based models like Flamingo. This hybrid architecture allows NVLM to leverage the strengths of both systems, enhancing training efficiency and multimodal capabilities. Another standout feature is the 1D tile tagging design. This might sound complex, but its purpose is simple. It dramatically improves NVLM's ability to process high-resolution images for tasks like OCR and dynamic image reasoning. This innovation allows the model to handle more visually complex data without sacrificing accuracy, making it invaluable for industries like document analysis and visual data processing. But the technology doesn't stop there. NVIDIA's approach to training data is another key differentiator. Unlike many AI models that prioritize dataset size, NVLM focuses on quality and diversity. NVIDIA curated a high-quality text-based only dataset to enhance its text-based performance alongside multimodal math and reasoning data to improve its problem-solving abilities across modalities. This meticulous approach ensures that NVLM isn't just versatile, it's precise. Finally, NVIDIA didn't just create a research tool, they developed production-grade multimodality. This means NVLM is ready for real-world applications, where accuracy, efficiency, and adaptability are critical. By excelling in both text and visual tasks, NVLM isn't just pushing boundaries, it's setting new ones. And if all of this feels like a glimpse into the future, it's because NVLM 1.0 isn't just about today. It's a blueprint for where AI is headed, showing us what's possible when cutting-edge technology meets visionary design. NVLM 1.0 seems to be a problem-solving powerhouse capable of excelling in diverse real-world applications. Let's start with its OCR, optical character recognition capabilities. Unlike many models that simply recognize text and images, NVLM takes it a step further by understanding the context behind the text. For example, it can analyze a scanned document, extract critical information, and even summarize it in a meaningful way. This makes it ideal for industries like finance, where processing invoices or receipts quickly and accurately is essential, or healthcare, where digitizing handwritten medical records can save lives. But NVLM doesn't stop at reading text, it also reasons. One standout example is its ability to understand humor even in complex memes. Imagine a meme that juxtaposes the abstract, a fierce lynx, with the paper, a domestic cat. NVLM not only recognizes the text labels, but also grasps why the contrast is funny. This kind of reasoning capability is a leap forward in making AI more human-like, with potential applications in content creation, advertising, and even customer engagement. When it comes to coding and math, NVLM shines just as brightly. It can analyze visual data like handwritten pseudocode or tables, and provide precise, step-by-step solutions. For example, it could read a whiteboard filled with equations, solve them, and present the results in a clear, readable format. This capability makes it invaluable for educational tools, where students can learn complex subjects interactively, and for professionals in engineering or data science who need quick solutions to intricate problems. Another impressive feature is the instruction following capability, which allows NVLM to tailor its responses based on user input. Whether it's providing a concise answer or a detailed explanation, the model adapts to meet the user's needs. This makes it an excellent tool across industries such as entertainment, where it can help scriptwriters brainstorm ideas, and education, where personalized learning experiences can transform how students engage with content. The versatility of NVLM 1.0 is why it's being described as a true game changer. Its ability to seamlessly switch between different tasks and contexts makes it a valuable asset for a variety of sectors, from healthcare to entertainment. In essence, NVLM is proving that AI can be both a specialist and a generalist, solving problems that previously seemed out of reach. What sets NVLM 1.0 apart from its competitors is its dual strength. On the one hand, it excels in vision language tasks, handling complex multimodal challenges with ease. On the other, it enhances its text-only performance, addressing a common shortcoming in other multimodal models. This dual capability isn't just an incremental improvement, it's a paradigm shift that redefines what's possible in AI. Take its performance on benchmarks like OCR Bench and Math Vista as examples. These aren't just numbers, they represent real-world problems being solved more efficiently than ever before. Its ability to process dynamic high-resolution images, reason through complex scenarios, and deliver accurate text-based solutions reinforces its credibility as a leader in the field. What makes NVLM even more impactful is its open-source availability. NVIDIA's decision to release the model weights and training code via Megatron Core empowers the entire AI community to build on its innovations. Researchers can now explore new applications, startups can integrate cutting-edge AI into their products, and developers can experiment without the constraints of proprietary systems. This move isn't just a win for NVIDIA, it's a win for everyone invested in the future of AI. In short, NVLM isn't just an impressive model, it's a catalyst for change. By breaking down barriers and setting new benchmarks, it's paving the way for the next wave of AI development. Its ability to handle both text and visual tasks without compromising on either is a clear indication of where the industry is headed. The release of NVLM 1.0 has sent shockwaves through the AI community. Competitors like OpenAI, Google, and Meta are undoubtedly taking notice, as NVIDIA's model challenges the status quo in multimodal text-based AI. The industry has long debated the trade-offs between specializing in one area versus excelling in many, and NVLM seems to have cracked the code. One of the most significant reactions comes from researchers who have access to a cutting-edge model that's also open source. This democratization of AI tools is expected to lead to a surge in innovation, as startups and independent developers can now compete with established players on a more level playing field. At the same time, NVLM's releases raises important questions for the industry. How will competitors respond? Will we see similar open source initiatives from other major players? And what does this mean for the development of more specialized models? While the answers remain unclear, one thing is certain. NVLM has set a new standard, and the ripple effects are just beginning. For consumer applications, the implications are equally exciting. From AI-powered assistants that can understand both text and images, to educational tools that adapt to individual learning styles, the possibilities are endless. With NVLM, NVIDIA has shown that AI isn't just about solving today's problems, it's about imagining what comes next. As we recap what makes NVLM 1.0 so groundbreaking, it's clear why it's being held as a turning point for AI. Its state-of-the-art multimodal performance, ability to excel across text and vision tasks, and open-source availability combine to create a model that's as versatile as it is powerful. By focusing on quality and innovation, NVIDIA has set a benchmark that others will strive to meet. But the impact of NVLM goes beyond its technical achievements. It's a model that's empowering a new wave of research and development, proving that AI can be both accessible and cutting-edge. As the industry reacts and evolves, one thing is clear. NVLM 1.0 isn't just shaping the present, it's building the future. So, what do you think? How will NVLM 1.0 shape the world of AI in the years to come? If you've made it this far, let us know what you think in the comments section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.